I do want to record it to the cloud. All right. So because it came up, no, I have not graded exams yet. And when you're looking at the exams, a couple of the things that you need to keep in mind, they are set up so that any anyone that does the work doesn't have to be 100% correct, just anyone that does the work, you should be able to get at least a C. For if you want to get that A though, then you have to do the work and do the work correctly. And when I go to grade everything, anytime you see like one of those open boxes on there, so if I'm asking you, uh, what is the probability of whatever, that should be worth 2 points. If you give me the correct answer, you get two. You give me something close to it, you get one. You toss something on there just to say toss something on there or leave it blank, nothing. If you read through the exam, and you've read every part of every question on the exam, you know that there are a lot of opinion questions on there. And as long as your opinion is based on the data or say your personal experiences, and it and the opinion is not sexist or racist, I honestly don't care what it is. So as long as you have an opinion, as long as you put in some thought into why you would do this, that, or the other. And I know there's the one problem about talking about the value of life. It's a horrible problem. It's something that does come up. It's something that does need to be considered. It's something that is generally not taken into account. And if we're honest about it, uh, let's say you've got that 76-year-old man who's sick, and let's say you've got, or it doesn't even have to be a man. Let's say you've got a 76-year-old person versus a 7-year-old person. You can only save one of them. Who do you save? In Western cultures, I think for the most part, most of us are going to say you save the child because the child has not had a chance to have a life yet. When my grandmother was sick with COVID, if she knew that she was taking up a respirator at the age of like 90 something, that could have been given to someone who had a family, had a growing family, that type of thing, she would have said, pull this off of me, give it to them, let me die. Now, if we are in Japan, though, and we ask that exact same question, uh, do you save the old person or the young person? The answer they're going to give, generally, you save the old person. Why? They have all the wisdom. They have a lot of knowledge they can pass on to the next generation. And in that case, what exactly does a 7-year-old know about the world? Pretty much nothing. Someone who's 76, they've seen some things, they've lived some things, and being able to impart that knowledge on to many, many other people is thought of as being more valuable than the life of a younger person. So if your opinion was you save the old person because whatever, fine. You want to say save the young person because whatever, fine. As long as it's not racist and sexist, I don't care. You got your 2 points on that. If I asked you to write me like 3 sentences on whatever, it's 2 points per sentence. So if you have 3 sentences or even more that are based on whatever, that's 6 points that you probably didn't even have to do much math on. So there you go. Anyway, for tonight's torture session of all of you, we will be using uh, I will be using a graphing calculator as well as a stats program that's freely available online. I will show you how to answer all the questions we're going to be dealing with in here uh, on or using the graphing calculator and this other piece of software. They both do exactly the same thing. So it does not matter which one you actually use to answer questions on the next exam. Choose which one you want. If you have the TI-84, T84 Plus or whatever, and you feel comfortable with that, by all means, go ahead and use that. If you don't have one, do not go out and buy one specifically for this class. Save your money, use the free software. I will be going over it with you. And I'll probably be doing the stat software that's available online in the second half. So I will let you all see what the website is so you can all go to it. And then we'll basically do the exact same problems over again, but this time using the online software. And then, because of everything else, we're going to be using or start to use SPSS. Probably I can show you how to do a bunch of things with it tonight really quickly. It's probably not going to help many of you at all. So this will be part of the web extra. And I will go through and try to show you all the different buttons I click on, and I'll leave it up there so that you have time. So you can have, say, the video, I don't know, over here, and say SPSS open over here, and you'll be able to hopefully click on everything. And if I seem to be going a little bit too fast for you because it is a video, what do? Set the playback speed to 0.75. Will it be longer? Will it be more boring? You betcha. But uh, you'll also have a better chance at clicking on all the right buttons. Okay. With that said, ooh, gotta flip this over. So today, is this the, oops, just hitting all the wrong buttons. Sorry. Uh, oh, that was the right button. Where's the exit? Oh, how about the escape? Jeez. Oh, sorry. Haven't used this thing in a week and almost totally forgot how to use it. All right. So if you look in a typical textbook, the material that we're going to be talking about today is usually covered in 2 or 3 different chapters. But if you try to read through all of those chapters all at the same time, uh, the beginning parts don't make any sense until you get to the later parts. So I'm just going to skip ahead to the later parts so that we can save some time, make sure you understand everything, and we can get into how to answer these types of questions and what we need to be concerned about. So we're going to be looking at what are called one sample and two sample uh, t-tests, and then one sample and two sample uh, proportions tests. With all of these tests, I'm going to be writing a lot of formulas. I do not expect you to use these formulas for anything. You're going to be using software. You're going to be using your calculator. Don't worry about the formulas. I'm just writing them down so we can see kind of what's going on with all of these. But the thing that we need to keep in mind are what are called the assumptions behind all of these tests. If we're doing a t-test, we have to assume that the samples are, and the little wavy equal sign here means approximately normally distributed. And we also have to assume If we're doing a one sample test, or sorry, if we're doing a two sample test, standard deviation for one of the groups we're dealing with is going to be approximately the same as the other group. Then, of course, I have to put a little asterisk there. Uh, this is going to be assumption that we use a lot over the next several weeks in class. And this asterisk just means, sorry, that should say unless stated, okay? So what's happening with all four of these, we're doing something called hypothesis tests. With our hypothesis tests, we're looking at two different versions, H naught or HO for original, HA, or we could even have it as H1 for the alternative. Essentially, with all of these hypothesis tests, oops, wrong symbol. So I'll just write these down here. So if we're doing a one sample t-test, we assume that the population average is equal to the sample average. The alternative is that they're not the same. If we're looking at a two sample test, we assume the average of group A is the same as the average of group B. The alternative test is just something is different. If we're doing so if we're doing the two sample t-test, if we're doing a one prop, depending on where you see this, it's either going to be a P or P0 is equal to P hat. In this case, this is the population percentage. This P hat here is our estimated probability or proportion that we're testing. And again, our alternative hypothesis is just that something is different. When we do a two prop, we believe that the estimated proportion of A, or for group A, is the same as the estimated proportion for group B. And again, they're different. So what we're trying to ask, the big question we want to know, just to make it easy for all of these, and this is going to be true for literally everything we do in this class for the rest of the semester, we're trying to answer the question, is there a difference? Only thing that really matters, only thing we care about, is there a difference? Yes or no? And we use these hypothesis tests to help us out with that. We have to we've got some other assumptions that we need to worry about with all of these types of tests. And these are also going to be true for everything else that we do from now on. So assumptions for all of our tests. So one is going to be that the sample represents the population we're looking at. Two, the only difference uh, between between groups, still can't write properly, whatever. is the one you are interested in. So the one of interest. Uh, there are actually a bunch of other ones, and I'm trying to think of them right offhand, but these are the really, really big ones, the really, really important ones. So, oh, samples are independent. If any of these three things are violated, uh, there is there's basically no reason to even bother with the data. Uh, Unfortunately, what happens far too often in the real world when you start getting into some of your higher classes and trying to analyze uh, data and journal articles and stuff like that, you're actually going to start to realize that a lot of these things are actually completely, totally, and utterly violated. And the person that's doing the experiment wonders, why didn't it work out? Uh, so a uh, quick rundown of what some of these mean in practical terms. And of course, there are stories, right? There's always got to be a story. So when I'm saying that the sample has to represent the population, I worked at Lawrence Tech University, and in 1 year, they hired a company to go out and interview people about whether or not they would send their kids uh, to Lawrence Tech for their education. And if they said yes, then they started looking into what is the price a parent or someone is willing to pay for their kid to go to Lawrence Tech. And the conclusion that was drawn from this data was it doesn't matter what the price is, then they're going to get the same number of students no matter what. Anybody see or think of anything that's like completely, totally, and utterly wrong with that thought and idea? You can go ahead and unmute yourself or put something in the chat if you want to.
Yeah, they can make the price as high as they want to make the most profit then.
Well, you have, when you're trying to figure out what price you can charge for a class or per credit hour or whatever, I don't know how much all of you are paying to be in this class with me, but one, thank you for paying that price to be here with me. But two, let's say uh, essentially a lot of the stuff that we do in here, I'm going to teach this same material the same way, almost anyways, to students that I'm teaching at, say, a community college. I think you guys are paying between what, $2,500 and $3,000 to be here with me. So again, thank you for that. If you were taking the same class with me at the community college, like at Oakland Community College, if I was teaching it there, or if I started teaching at Macomb or Mott Community College again, you'd be paying what for that stats class? Maybe $1,000. I honestly don't know anymore. So, and if you take it over at say Kettering, you're paying say 3,000 for the class. You take it at Kettering, and you could take it with me, all three places at least at one point, and you'd be paying $6,000 to $7,000 for the same thing. Are any of you willing to pay $7,000 to take this class with me, say at U of M Flint? And it's okay to say no, because I know I would say no. So when they came back with the conclusion that price doesn't matter, that should have set off a whole bunch of red flags. What what was the sample of people that they actually contacted, alumni. The company they hired talked to a bunch of alumni, so people who graduated from Lawrence Tech University, and asked them if they had kids. If they said yes, would they send them to Lawrence Tech? If they said yes, then they asked if classes were at the time, because this was 2000, maybe 1995, something like that. So before I was there, but they charged, say, $500 per credit hour. Would you send your kid there? They charge 750 per credit hour. Would you send your kid there? If they charged 1,000 per credit hour, would you send your kid there? And basically everyone's like, yes, 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 yes. Well, because the sample only represents alumni, not future potential alumni, the population or the sample does not represent the population they're targeting, which means they spent all this money to get literally garbage. And they fully and firmly believed their garbage. Problem was, a couple years, or I think it was the summer after I left there to go elsewhere, they found some major accounting mistakes in many of the accounts on campus. So, just as an example, if we're talking about U of M Flint, every department has a certain budget to buy equipment, re replace things that break, blah, blah, blah. Those are all going to be kept in separate accounts. So, Lawrence Tech had, say, as a university, had, say, 150, 200 savings accounts or checking accounts, let's say, at a certain bank. Some of those accounts were overdrawn by over $1 million apiece. Some of those had uh, adequate funding in them. The university got audited. The university lost. Then the university found out that it needed to repay, like, say, $3 or $4 million because of accounting errors, because literally the people that were in the accounting department did not know how to use the accounting software they were supposed to use. Just an example of what was going on. Suppose you've got $20,000 in your checking account, and if you do, congratulations. And let's say you've got $20,000 in your checking account and you spend $10,000. How much do you have left? If you know how to do simple math, you say $20,000 minus $10,000, I have $10,000 left. What did they do? They went into their accounting software and somehow got it to add that amount. So according to the university's records, you have $20,000 in your department account. You spend $10,000. How much do you have left? You now have $30,000 left. Now that you have $30,000 left, you spend $25,000. How much do you have left? You have $55,000. You spend $50,000 now. How much do you have left? 105,000. See a huge mistake going on here? So in order to make up all of that money, they had to raise tuition. But because they firmly believed the garbage that they were told, because they believed survey data that failed a basic and highly important part of a survey, uh, they ended up having student enrollment drop significantly by like 2/3. For the students that were there, and as students at U of M Flint, imagine you sign up for your fall class, or sorry, you sign up for your winter classes, and you pay whatever it is. And let's say you can enroll right now and you pay it off or pay off that class today. Then in early December, they send you a bill for the exact amount of money you've already paid. What's your first thought going to be as a student? Anybody want to chime in on that? So if, yeah, and a lot of the students saw that and were like, oh, those idiots. I already paid this. End of December comes up, start of January comes up. If you enroll in a class and you did not pay for the class yet, one of two things will happen depending on what university is and all that sort of stuff. You either get kicked out of the class, or if you've paid part of it, on the part that you did not pay, you're now going to pay a fine on that. So now the students are getting a bill for the amount of money that they already paid, exact down to the penny, plus a fine. Why? Because the university doubled tuition in a 2-month period. So a lot of students, if they could transfer back to another university, decided, bye-bye, I'm not coming here. This is a joke. They left and they got their money back. For the students that had scholarships and all that, they stuck around. If you're not paying for it, why would you leave, right? And for some of the students that were really, really close to finishing, they're like, what? I now have to pay how much extra? And if they wanted to transfer, because it was done so late in the semester, none of the other universities are actually enrolling at that point. So they can't transfer this. So they've got a choice of uh, to do this for the one semester, and then they can transfer after that, which a lot of the students did. That cost the university millions of dollars in now money, millions of dollars in tomorrow money, because all the students that would have enrolled that left, they're not coming back. And other students that now wanted to enroll, they're looking at it and went, well, 2 years ago it was $500 per credit hour. That was expensive. Now it's 1,100. Are you kidding me? For that much? For the price of one credit there, you can go to the community college or your public university at the time and get the same class. Are you paying 4 times more just because, oh, it says Lawrence Tech on it? Absolutely not. So when it comes to this assumption about the sample represents the population, if you really, really get into things, uh, you will find that this is violated frequently. When you see that that is violated, there are two options for you. Um, if you want to be kind, if you want to be considerate, you would ask, how do you weight all the different people that say were essentially were not part of the sample that you looked at? Or if we're talking about politics, and let's say, because I'm teaching down in Dearborn, if I want to ask people how do they feel about the Israeli-Palestine ceasefire peace agreement with Hamas and all that sort of stuff, but instead of talking with the majority population of Dearborn, let's say I only talk with Black women about it. Do Black women represent the, and I know Black women, white women, or any group are not a monolith, so they don't all think exactly the same way. But do you think that, say, Black women have the same thoughts about what's going on in the Middle East as, say, a Muslim woman or a Muslim man? I would say no. I could be wrong, but in general, I would say no. So if you talk with 5,000 Black women in Dearborn and then try to use that as We talked with 5,000 people from Dearborn, and this is their opinion about what's going on. Your sample does not represent the population, so nothing you can say about it matters. Now, there will be times when you try to pull a sample from the population, and let's say we know in the Metro Detroit area, I put and these are still kind of accurate, but don't quote me on it. But like, let's say in the Metro Detroit area, the population is 70% white, 20% black, and 9% Latino, Latina, Hispanic, however you want to put it, and say 1% other, whatever those other groups are. Now, if you go and you start talking with people in the population, and instead of say 70% of your sample is white people, you get say 80% white people, 15% black, not 20, 7%, if these numbers even work out, let's say 7%, or 5% Hispanic, Latino, however you want to put it, you can actually come back and you can kind of weight everybody's opinion based on the group that they're in to make it look more like what the population might be thinking. But again, if I'm trying to figure out what do people in Dearborn think about the Hamas Israeli ceasefire deal and all that sort of stuff, and I only talk with Black women, do Black women represent the general population of Dearborn? Not even close. So you may have spent all this money, and if you hear about any of the people that or how much anyone ever see those petitioners or the people with the petitions that you can sign? They get those people that you meet out in the street usually get paid, say, $5 to $10 per person that they register or they get to sign as long as it's valid. So, uh, 5,000 people, you just spent $50,000 for garbage. What else could you have done with that $50,000 that would have been more useful? Uh, Throw it in a money pit, light it on fire, roast marshmallows, make some s'mores. Would have been a much better use of $50,000 than than sending people out to get all these samples. Uh, Assumption number two for all of these is that the only difference or only major or only important difference between the groups you're looking at is the one of interest. When you look at a lot of, say, education research, they violate this quite often. I used to work at Henry Ford College in what's called their institutional research department. And I used to get analytics requests from people all around the college. And some of them were asking really important, useful questions. Where when I looked at the questions they asked, I literally had to run them against all of these assumptions that we were just talking about. And I'll flip it over so you can see the assumptions in a moment. Uh, but if they followed all of that and I knew what they were trying to do with the data, what question were they trying to answer, run the analysis, send it to them, say, here is the outcome. Here is what the data is telling us. If you want to improve student performance, you need to do this, whatever it is. But there are other people, especially those that had the degrees in education, who would have start asking questions like, what is the difference in success rate between, say, 18 and 21-year-old Black males and 35 to 40-year-old Latino or Latino women? Between those two groups, what is the only one difference that you can think of? Since I'm talking about Black young black men versus middle-aged Latino women, what are the only differences? Or what is the only difference between those two groups? And if you're confused, well, gender would be one, ethnic group, age group. Uh, since I have some people that are, say, early 20s and some other people here that are, say, definitely not in their early 20s or 30s, uh, for the younger people in the group, do you think your opinion is going to change on things over time, over the next 20 years? Do you think that how you behaved as, say, a 16-year-old in high school is the same as you're behaving as, say, a 21 or 22-year-old in university? So we've got a whole bunch of different things that are going on here. We're looking at one different one difference. And here we've got ethnicity, race differences, we've got age differences, and we've got gender differences. So we've got three different things that could be hugely impactful and they're all just basically being ignored. Well, we're trying to figure out of which group does better. Why? Are you taking bets on this? Um, are there's I can do the analysis. The software will give me a result. The result, again, total, utter, useless garbage, completely pointless, and a complete waste of my time doing it, complete waste of their time even thinking about doing it. But that sort of stuff happens quite often in educational research. One of the things that we're going to get to a little bit later is if we use more sophisticated methods, we can actually take into account race, age, gender, say income level, uh, what's your grade point average in high school? How long ago were you in high school? How long do you take between taking classes? We can see the impact of all of these things simultaneously, and we can answer a lot or answer the same type of question, but do it usefully. So again, with what we're talking about tonight, what we're going to talk about next week, we have to assume that the only difference between the groups that we're looking at is that one thing that was specified. And for number three, samples are independent. With my business class that I'm teaching, we covered a lot of this stuff uh, in the previous few weeks. I will make the videos I made for those classes available to all of you. They are newer classes. They're also quite a bit more in depth because quite literally everything we're doing in the rest of this class for them is the entire semester. So if you're thinking that I'm going over this stuff really, really, really quickly, yes, yes, I am. What's the alternative? Instead of doing one class, you take two classes. Anybody want to pay for two stats classes, or are you happy just doing one really, really quickly? That's on you. Don't answer that. But with the independent stuff, if we're talking again about, um, and this is going to be true for everything that we do, the samples have to be independent. What does that mean? If we're again, say doing the polling, and I am looking at all the people that are up here, and if I'm correct, everyone is female, and I've got white and black women up here right now, if I'm correct about that. So let's say I require all of you to turn on your camera, and I'm not doing this, so don't don't do it if you don't want to. Well, let's say I require all of you to turn on your camera. I require all of you to turn on your microphones. And then I start asking you uh, say opinion questions. When you hear someone else in the audience or in the group that we're looking at or that I have right now talk one way about something, is that going to influence or potentially influence how you feel about that? Most definitely. If I ask an opinion question and you honestly don't care because you don't care, that's a completely fine response for me. But say four of you keep talking about how it's really important that blah, 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 is that one person who thinks, I don't care. I just don't care. It doesn't affect me. It doesn't do anything good or bad for me. Whatever. I couldn't care less about this conversation. Is their opinion now all of a sudden going to start turning to, yeah, I guess it is kind of important. So because of this idea of peer pressure, trying to talk with or have all of you talk about it at the same time, especially where you can look at each other, that's going to make for, say, a lot of really awkward moments. That's going to make some of you who, like I said, you don't care, and that's fine. But because you've got three people, four people that are saying, this is the most important thing ever, blah, blah, blah. See, like he thinks being pet right now is the most important thing ever. Uh, you are probably going to change how you feel about it. Since you change how you feel about it, not because you actually care. It's just say you don't want to get into an argument with your classmates about the importance of whatever. And again, I don't care what it is. If I used you all as a focus group, my results would be pretty garbage just because the independence of the samples has been violated. And again, that sort of stuff happens all the time. Um, if I have all of you in the room and let's say we watch a couple videos, and then I ask you to secretly and independently write 5 sentences on how you feel about the topic and let you know that it's completely fine to say, I don't care, or I don't like this, or I do like this, or whatever. It's what do you feel? And there are no wrong answers, just points when you give me an opinion. That's going to be more of an independent thing. So we need to watch out for those three things. They do get violated quite often. When they do get violated, they tend to be completely, totally, and utterly horrendous. They that invalidate anything you can say about the data, anything you can say about anything, but people are still going to do it. Totally useless, totally garbage, but they're still going to do it. So, a couple examples. And I will say, with the problems that I give all of you on the second exam, the problems that you get on the final exam, you can assume that everything I'm telling you here about samples were collected independently, uh, the sample represents the population, uh, the the only thing that's different between the two groups is the one thing that we're talking about or the thing we're talking about. You can assume all of that is true. I'm not going to test you on how well you can sniff out uh, certain types of biases. It's just assume it's all good data. In the business stats class, it's because we have the time, it's do you think the data is biased? Why do you think the data is biased? And we get into that, so you don't need to worry about that. But let's get into this. When we are dealing with these hypothesis tests, and let's say we are testing, we believe, so this is going to be a one prop test. Depending on the software you use, they might call this a one prop Z test or one prop test. So whatever. Our null hypothesis is that the value we find when we start polling people is going to be equivalent to the true population. So, and then the alternative hypothesis we have here is just going to be these are not the same. Okay. How do we test a hypothesis? We have three different ways to do this. One is to look at a what is called a critical value versus calculated. When we do these types of things, what's gonna, sorry, I'll pick up on what that actually means in a moment. Two, we can look at a p-value. Three, we can look at a confidence interval. With the p-value, what we're looking at, since this is the easiest one to actually draw, we have essentially a number line that's going to go from, say, 0 to 1. We are going to have a region here that most of the time when you look in most textbooks, it's shaded in. This is based on something called an alpha value. So 1 minus an alpha value gives you an idea for the percentage in your confidence interval. So if I say a 95% confidence interval, alpha is going to equal 5%. If I say a 90% confidence interval, alpha is going to equal 0.10. If I say a 99% confidence interval, alpha is going to equal 0.01, and so on. Something that we're going to find essentially only next week. So if this stuff confuses you next week, don't worry, it only happens once. But when we're looking at confidence intervals, those are like the three main confidence intervals that we look at. Just because of how statistics is with data, especially with what we talk about next week, you're going to have some really awkward confidence intervals. If this was 1925, I would say, well, just look these values up on a table and blah, blah, blah. Because we're dealing 2025, you look at whatever your calculator or whatever your software gives you, and then you go with that. So that makes things quite a bit easier. But if we have a p-value that is in the shaded region, basically we're going to assume H naught is shady. Do you trust shady people? I hope not. So when our alpha value is in the shaded region, the traditional statistical terminology here is to say we reject H naught, We believe uh, there is uh, sufficient evidence, blah, don't worry about it. But it's basically, we're saying we don't trust the null hypothesis. We think we see a difference. So if we have something out here, we say fail to reject H naught. And then if you look in the statistics textbooks, what does it tell you to say with that? Uh, we fail to reject H naught. We do not have sufficient evidence at this time to prove or potentially prove that there may or may not actually be a difference between the group and the population, or the two groups that we were dealing with in this particular case study, blah, blah, blah. And if you uh trying to memorize all that stuff, don't bother. When we fail to reject H naught, we just think they're the same. So the weird thing is, there will be some times when you look at the data. Go ahead, Abby.
So we reject the hypothesis if it's not in the alpha value.
Um, if it's in the shaded area,
Uh-huh.
we reject. If it's in the
Reject.
clear out here, we
Yeah.
fail to reject. Another way to think
So that
about
means
it,
we accept it then?
only if you want to start a fight with statisticians.
Oh, I'm confused. I don't get the difference between like if we reject it when it's shady and then fail to reject.
Statisticians and mathematicians have a deeply held belief that the terminology they use has very specific and unique meaning. Should you be, say, an English major or an English minor, or a communications major or a communications minor, Abby, you're going to say the same thing you did. So we either reject it or we accept it. If you go and you look in a thesaurus, what is a synonym for reject? What is an antonym for reject? The antonym for reject, so the anti word for reject, one of those that comes up is going to be accept. And if you try saying that to most statisticians, they're going to have an absolute fit, because they firmly believe fail to reject is not the same as accept. And then you look at them and say, so if you fail to reject the null hypothesis, do you continue believing the null hypothesis? And the answer is yes. So you've accepted that you don't have enough evidence to prove there's a difference. And then hopefully their head explodes, and or something happens. They bust a vein in their forehead or something, and then pass out or whatever, so you don't have to deal with them anymore. But you are correct. If you use a thesaurus, if you know the meanings of English words, saying we accept the null hypothesis is completely fine. But you tell that to most statisticians, they will have a fit about it. They will try to correct you on it. Personally, I couldn't care less. The way that I look at this, the and because the consequence of everything that we're doing here as well is basically, we're asking the question, does there seem to be a difference? Yes or no? If we fail to reject H naught, we believe there isn't a difference until we gather more data to prove otherwise. If we reject H naught, we believe there is a difference So we start making decisions based on that. So if on the exam, if you were to say, I accept H naught, I'm not going to mark you down for that. However, if you take like the epidemiology class, which I think requires this as a prereq or something like that, and you say, I accept the null hypothesis, you might get a point or two taken off on an exam because you didn't say, we failed to reject the null hypothesis, blah, 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 blah. So, which just means, depending on who you're talking to, you have to change uh, the words that you use. Is that annoying? Yes. But is that what ends up happening? Yes. So when you look at the confidence interval, again, that tells you what the alpha value is going to be. And the larger the alpha, the greater the chance is that you're going to reject the null hypothesis. For the most part, if I write a question in the exam, or if any of you are reading a journal article or whatever, and you see in there a confidence interval and they don't mention what the level is, the basic assumption is that it's going to be a 95% confidence interval. Keeping to 95% confidence interval makes things easy for other people to understand. Are there issues with keeping a 95% confidence interval no matter what? Yes, yes, there are. For me, my general thought is the smaller the sample size, the larger the alpha. So as an example, if I am going to do, say, a taste test uh, with the 5 of you that are currently here, that is a small sample size. I'm going to use a 90% confidence interval. If I'm going to be doing a taste test with 300 people, 500 people, 95% confidence interval makes a lot of sense. If I'm going to be talking with 20,000 people, I'm going to make my confidence interval 99%. The more people you get, the easier it is to see smaller differences. And what we need to be concerned about are, say, meaningful differences. And just as an example of what I'm talking about here, uh, if we do what would be called a paired t-test. If I had everyone in the class right now, everyone in all my previous classes, and I forced them all to perform or participate in this experiment, we could look at a simple and easy weight loss reduction by basically shaving the hair off of all the hair. So on the top of the head, eyebrows, you got hair on your arms, armpits, legs, wherever. We're shaving it all off. We're going to weigh you before we shave. We're going to weigh you after we shave. And I guarantee we are going to find a statistically significant difference if I have enough people. But is losing 4 ounces and 4 ounces of body hair worth it? No, I would say no. Maybe if you're already bald or completely bald or something like that, probably don't matter to me. Okay. But for the 5 of you that are still here, how many of you would be really, really mad if you had to shave off all the hair on the top of your head? Anybody want to answer that one? So, so again, um, we need to be able to set an idea about what is a practical difference. And that's a whole lot of other stuff that we need to get into. With the confidence interval, you've already kind of been familiar with that. So let's say I find that the confidence interval for this proportion I'm looking at is 25% to 35%. So my estimated, or my point estimate, so that p hat, that's going to be 30, 30 plus or minus 5%. So if you go out, or if any one of you go out and you poll people on the same thing, and let's say Brooke comes back and says, well, I found that the people I polled said they were 28% in favor of this. And Abby goes out and gets 33%, and Lonnie gets 31, and Destiny gets 34. All of those values are in the confidence interval. So there is no statistically significant difference. Sorry. On the other hand, it's say Verlin goes out and finds there's a 40% favorability rating. That's outside of my confidence interval. So I'm going to say it looks like there is actually a statistically significant difference between what I found and what Verlin found. Am I saying I did something wrong and Verlin is right? Am I saying Verlin is wrong and because what I did is right? Well, we honestly can't say any of that. We have to go back, look at the data that was collected, look at the different assumptions. If my data abides by all those assumptions and Verlin's data abides by all that assumptions, we are both correct. We have we have statistically significantly different answers, but we can't we can't prove the other one made a major mistake. And if it's not a mistake, so you can think of it if you're playing sports, if you don't lose, by default, it's what? Either a tie or a win. So you can't prove them wrong, they must be right. Uh, with the critical value, dear God, that's horrible. But I'll show you what it is really quickly. And with what I'm doing here, this is general. If we're dealing with proportions, t-tests, next week we're going to talk about ANOVA. After that, linear regression. We're going to be having these ideas here. Basically, all of those assume essentially a normal distribution right down the middle here. That's going to be X bar. The critical value uh, is going to be whatever value we have here, or whatever value we have out here. So what I've been telling you is when we're talking about a standard confidence interval, it's basically plus 2 standard deviations or minus 2 standard deviations. The area from here to here is the confidence level. Because it's -2 to +2, this one in particular is going to be a 95% confidence or confidence interval, or at the 95% confidence level. And these critical values are going to be based on 2 times the standard deviation, whatever that happens to be. For a chi-squared, or for an F-test, we're actually going to be talking about both of, actually this one, probably talking about it later today. This one definitely next week. Both of these look something like this. And there's only going to be one critical value here. And the way that these work, if you get a value that's in this area, or you get a value that's in this area, we fail to reject H naught. Up here, if I get a value out here or out here, we reject H naught. Down here, if I get a value that's out here, reject H naught. So just as, for instance, you do a chi-squared test, the critical value here is, say, 4.0, but your calculated value is 9.7. This 9.7 is greater than this critical value, so we reject H naught, and we believe we found a difference between groups that we're testing. And that's all that we can say. We need to go back and do some further investigation to figure out what groups are different, but that's how it works. And up here, if we get a value that's out here, we say reject H naught. We believe we found a statistically significant difference between the groups that we're testing. And to be honest with all of you, I don't memorize all those critical values. I have tables. I'm not even going to bother to try to pretend like I'm going to look these values up on a table. All I'm going to do, I'm going to ask a computer, what is the value I should be looking at? How should I be looking at that value? Um, and then go from there. All right. I was just going to flip the or show this again really quickly. So we have three different ways of testing the hypothesis. The most common one is to use this p-value. To me, the most valuable answer is to use the confidence interval, but they're both based on these critical values. So I'll flip that back over for you. Part of the reason why I like using confidence intervals is, go ahead, Brooke.
Say like how are we finding out the critical values? I guess maybe I missed that part, or I'm just like I'm just thinking about like in use. Like if we have a problem or we come into real life, and is it gonna say this is critical value? And then I don't know if that made sense, but I'm
Well, depending on the software you use, it will either give you the critical value and then give you a whole bunch of other information, or more likely, it couldn't even be bothered to give you the critical value. And now my cat believes it's critical that I pet him. Come on, go, go. Let's get. So, again, if this was the 1925, what didn't we have in 1925? We didn't have calculators. We didn't have computers. There were machines they had that could do a lot of different calculations. Uh, but depending on how many calculations you did, it could actually be faster to do it by hand. So if we're going to be looking at critical values versus calculated values, that's a 1925 way of doing things. You can do it. Why? With the critical values, it also requires for you to do it correctly and accurately. It also requires that you have essentially uh, a book, sorry, a book that was about that thick. So by comparison, My algorithms textbook has well, you can almost see it, but it has 1,292 pages in it that are numbered. That's not counting all the blank stuff in the back. So you can see how thick that is. You need to look these things up in a book that's even thicker than this to find out what is the most exact and true critical value from a table. By the time you've done that, uh, it's 3 weeks from now. Good luck with that. And then you also have to realize this is something a lot of mathematicians don't like to talk about. When you go and you look up numbers in those tables, they were made by humans. What are humans really good at? Making mistakes. Do mathematicians make mistakes? You betcha. And if you're doing it by hand, and let's just pretend here for a second. If I do the math and I show it to you and you look it over and you go, okay, are you and you have to do it by hand and it's going to take you 45 minutes to do it by hand. Are you going to put forth the effort to do it by hand to make sure that you get the same value I do so that we can put this as a number in a book? Absolutely not. So there are a lot of mistakes in there. So even if you have that really, really thick textbook or that really, really thick book, still doesn't mean you can accurately use the critical values all the time. But the p-value, like I said, is the most popular way of doing this. The confidence interval is the like the next easiest way to do this. I'm gonna flip over to this really quickly. And of course, now that I've got that camera on again, my cat's decided he must be back on camera again. You can leave, mister. There you go. So if I've got a one prop test, and for the calculator, it's going to be one prop z test. H naught here is going to be that the population proportion is equal to my point estimate. So we can also think about this, we can also think about this as being the average. HA is basically going to be, they're not the same. So based on what some of you found when you started doing homework number 1 with the student data, let's say for a certain class, P0 has 53% of its students passing. You looked at a particular professor, and you know that that professor has taught 100, 200, 300 students in that class. So, and when you look at the percent of students that pass with them, let's say you found that there were 0.67, so 67% of their students pass. And we want to test that against the population average of 0.53 and ask the question, is there a difference? Yes or no? And I'm going to do this with n equals, let's say 10. I'll do 10, 100, and then 1,000. And what I'm going to look at here is the p-value. And with the calculator, it's going to give me the z value that was calculated. And then we're going to look at the confidence interval for these, okay? And just looking at what I've got there, I might have to change this from 10 to say 30. Show you what I'm talking about in a moment. Or actually show you what I'm talking about right now. So what's going to happen is we've got p hat. And this is a formula that we talked about week 2 of class. So we've got the x value here is the number of, say, outcomes of interest. N is the number of opportunities. So what ends up happening is with the online calculator, with the stats calculator, we need X and N. A lot of times when you look at polling data, you get the point estimate. So what they believe is, say, the popularity of a candidate, and then the number of people that they talk to. So how do we translate that into X? Because you all totally remember everything you've ever learned from your Algebra 1 class. We have to multiply the probability of the event occurring times the number of opportunities to give us this. And again, because you totally remember everything from week 2 of class, you remember that the expected outcome is equal to the probability of the event occurring times the number of people that you're dealing with. So for this, if I say x over 30 equals 0.67, to get x, 0.67 times 30. I'm just going to pull up the calculator. I'm not going to try to pretend to do this in my head. So 0.67 times 30. So this gives us 20.1. Now, when we look at this, we have to round that, and we're actually going to make it x equals 20. And I know that there's a lot of stuff that's going on here right now. We will do 2 more example problems. Go ahead, Abby.
What was X again? What does that 20 represent?
So just so that we have some things to look at and some things to talk about, I'm looking at, so again, we're pretending that when you looked at all the data in week 1, or for week 1 homework, or the week 1 lab, you found a professor that passes approximately 67% of their students in a particular class. And I'm saying we're actually going to look at 3 different professors that do this. And we're going to compare that against the class average for that college or university. Now I'm just saying it's 53%. So for the first example problem, we're assuming that the professor has only taught 30 students. 67% of them pass. So this 20 represents the number of students that pass. So the number of outcomes of interest, since we're interested in did a student pass, is 20. How many students did they teach? They had 30. Does that make sense?
Yeah.
Okay. So when we look at 30, Oops. Gotta share this. So what we do is if you have a TI-83, we're gonna do this 3 times. And sorry, I'll even try to make this a little bit larger. And for those of you that are gonna be trying to do this later on, which I suspect is gonna be quite a few of you, if you look down here where it says a key press history, because you can clearly see that it says key press history down here. You can follow along with all the buttons that I'm pushing here. So my first step is I go to this stat button and click on it. My next step is to hit this arrow over button 2 times. And you can see down here, it says item number 5 is a 1 prop Z test. Because I'm only testing because I'm testing a group against a population, I'm only testing 1 proportion. So I have 2 options. I can either hit the down arrow until I get to this point, or I should be able to just hit 5 and have it do the same thing. I generally use the arrows no matter what, just because I'm used to it. Once I've got it there, I hit enter. So the P0, the proportion of the population proportion is 0.53. For this first example, 20 students passed out of 30 students with a certain professor. We're trying to test, does there seem to be a statistically significant difference between this professor and the population average? When I look at the stuff that's down here, if all I care about is there a difference between these two? The thing that I've got right there is the correct, or what's blinking is the correct thing to look at and touch and use. But let's say we're going to try and make this a little more realistic. As a student, do you really care if the professor is different? Or do you want the professor to see if the professor is better than average? What do you think? So more than likely, it's going to be better than average. So what you can do is we can look at a one-sided test. If all we care about is the proportion for this professor greater than the population average? I will use this thing at the end here. I'm not going to do that right now, just so we can see what's going on. Now I'm going to hit calculate. And the Z value that was calculated is 1.4998. Call it 1.5. I'm not going to be that picky. The p-value, this is where it gets a bit interesting, because there's a p-value and then there's this p with a hat on it. The p-value we want is that thing on top, which is 0.13366. If you want to call it 0.134, I'm totally fine with that. Now, if I go back and I want the confidence interval for this, I go back to stat. Again, do 2 clicks over to test or tests. But this time I just start mashing the down arrow. So on this calculator, you see here that it's a 1 prop Z int. That gives me the confidence interval for the 1 prop Z test that we just did. So I'm leaving it up here for a moment so we can all see. Once I'm there, I hit enter. all of my information from the previous test will be entered in here. So I do not need to put more information in. I can also change the C level, that's the confidence level. If I don't say use a certain value, default is 0.95. I'm going to come down here and hit calculate and then enter. And you can see that the confidence interval here goes from 0.498 to 0.835. So what we get here, so this value that we have on top, and I wish I could highlight it without the computer doing stupid stuff. So about 50% to 83%. That is something that you've actually been calculating since week 2. But again, that's the estimated proportion for, say, the entire population, meaning what? If you come back 10 years later and that professor has, instead of taught 30 students in a particular class, is now taught, say, 400 students, that same class, when you look at what is the true proportion of students that pass, based on our small data set, we expect it to be somewhere between, what was it, 50 and 83%. Our best guess right now is 67%, but anywhere between 50 and 83 is fine. Since 53 is within that 50 to 83 range, failed to reject H naught, we do not believe there's a difference. Because the p-value is greater than 0.05, it's in the clear. We failed to reject H naught, or at least for right now, we accept the fact that we don't see a difference between these two professors. I'm going to flip this back over. Oh, sorry, can't. Need to cancel that. I'm going to flip this thing back over. So if we're now going to do this for the 100, again, I need X for the calculator. So that's going to be 0.67 times 100. When we look at that value, it's going to be 67. So in this case, I'm saying 67 out of 100 students passed with this professor. So now if I share the calculator again, and after I get done with the third one here, we'll take like a 10-minute break and we'll look at a couple more of these types of problems, okay? So when you look down here at the key press history, this is literally every button I had to press to essentially answer one or two parts of a problem that you are, or the type of problem that you are going to have on the upcoming exam. So yes, that is a lot. I will leave all the keystrokes and all that up on the screen. So if you are trying to see what they all are, you can pause it. So now that I'm going to be looking at this, so I'm going to go back to clear so we can see everything that happens. Going to clear that out. Do you need to clear all the stuff out? No. I'm just doing it so we start with a fresh slate. Now I'm going to go back and do this test one more time, but with our updated numbers. So stat. Then we go over to tests. For the one prop test, we come down to number 5. Then hit enter. Since my proportion is the same as before, it's staying as it is, but I'm now saying 67 out of 100 students with this professor passed the class. Now we're going to come down to calculate, and I'm going to hit enter. And the p-value here is 0.0050. The z calculated value is 2.805. And the confidence interval, again, once I've got this information, I have to go back to stat, over to calc, or over to tests, start mashing the down button until you get to A. And because it's probably going to happen if you mash the down button too much, you can mash the up button until you get back to what you need. So it's not like you have to restart the whole thing. It's not like trying to program the your alarm clock or something like that, where if you overshoot the time by 2 minutes, you have to go all the way through every number until you get back to it. So I'm going to hit enter here. All of my information from the previous test has already been entered in here. So I literally just mash the down button again, and I hit enter. And this time we see that the confidence interval is 0.5778. So I'm going to say 578. So with these types of confidence intervals, rounding it to 3 numbers is going to be perfectly fine. On the high side, 0.762. So going back to our data, we can try to use the z calculated value versus z critical. For this type of test, the z critical value is essentially 2. This is less than 2, so it's telling us not significantly different. This is telling us it's greater than 2, so that's telling us it is statistically significantly different. But again, the p-value up here is what's commonly used. And don't be fooled by what's written here, 0.005. We're comparing this. So if we go back to this number line, so we're looking at our shady area here. That shady area is going to be 0.05. This p-value is telling us we're at 0.005. So it's also telling us that there's a statistically significant difference between these two groups. We can also look at the confidence interval. The lowest value we expect for this professor's future population pass rate is going to be 57.8. If everyone that's ever taken the class, the average is 0.53, 0.53 is much lower than this, which also tells us there's a statistically significant difference going on here. And I'm going to do this one more time with 1,000. So again, x equals 0.67 times 1,000. So this is telling us x is going to be worth 670. So again, this is 670, oops, almost got it on here, out of 1,000 students that this professor taught passed the class. Go back to the calculator one more time. I'm going to do this one a little bit faster. So hit clear out all this stuff. So again, stat, tests, mash it down until you get one prop C test, enter. 0.53 has not changed, but now I've got 670 versus 1,000. I'm still doing this same versus different as opposed to same versus better. Come down here to calculate. hit the enter button. The z-score for this particular test is 8.87. The p-value 7.39 e -19. And we'll do the confidence interval really quickly. So again, I can go to stat, over to tests, just start mashing the down button until we get to A. Enter. Everything's in there already, so I just start mashing the enter button if I really want to. And this is telling us that the confidence interval for this is 0.641 to 0.699. So some of the things that happened here. When we had a small sample size, it's hard to find a difference. You increase that sample size, it makes it easier to find a difference if one exists. And looking at this value right here, one of the big mistakes that students make actually deals with stuff like this, but I will actually leave that. According to my computer, it's 7:09. So let's meet back at 7:20 and we'll talk about the big mistake that everyone made, or a lot of students make with that, just so you can see what's going on, all right? And I am actually going to step away for a moment. So don't try to ask any questions too quickly.
I got a quick thing before you go. It's quick, I swear.
What's the question?
Can you just put your calculator back on the screen? Or did you already cross it out?
Like that?
Yes, thank you. Okay, I'm good now.
So a whole lot of button mashing. Is it a lot? Yes. Does it get you what you need? Yes. And will I be back in about 3 minutes? Yes. So give me a
Okay.
moment.
Oh boy, there's the cat.
Hey, Brooke.
Oh, my mic's on. Oh my goodness, I'm so sorry.
No, that's okay. I actually have a question for you.
Yeah.
Maybe you can help. I don't know. I'm
Yes.
trying to plug in this information he was just going over into the calculator, like to do the prop test,
Yes.
and I'm getting error. Were you able to do it?
I don't have a graphing calculator, so
Oh, okay. Okay.
yeah, I'm not gonna lie, like I really don't understand this at all. I'm like gonna
Okay.
have to rewatch this on my own time. Like I had to step out like at the very beginning when he was like
Uh-huh.
doing his little chart and
Uh-huh.
like I missed that 10 minutes and now I'm like totally lost.
Okay,
I'm
well, I'm still lost and I was at the 10 minutes, so it's okay.
and
Yeah.
does he put
So
the
there,
so,
oh,
sorry,
well, no, it's fine.
professor.
I was just gonna say, there are some issues that do come up. Um, so I'm gonna flip over to my table really quickly, and hopefully my cat will hop down so you can actually read everything on it. Go away, kitty. So if I stop the share, so when you're looking at the data that I copied over, 0.67 times 30 gives me 20.1, okay? Now, if I put that number as is into the calculator, and I will say right here, right now, this is an issue that comes up every once in a while. So I'm going to clear this out, clear the screen off. So again, just really quickly, go to stat, over to tests, down to one prop Z test. So this P0, the calculator is expecting you to put it in as a proportion or as a percentage. It expects X and N to be integers. So if I put this in directly as 20.1, and then I say it down here out of 30, I come down here and hit calculate. Oops, should be out of 30, not 300. Sorry. And I come down here and calculate. It will give
Oh,
me this error message.
okay,
So
yeah.
that is,
That's what my error was.
well, I will say that's one potential mistake that you can make here.
Yeah.
So since it doesn't give me a go-to option, I'm going to hit quit. Another potential option, and this again is something that students make mistakes on. So back to the one prop Z test. So let's say I know that I need to have X equals 20, N equals 30, but I totally don't remember the order they go in. And let's say I put them in backwards like that, okay? Now, if I hit enter, it gives me the exact same error. So when you're looking at that, when you get the error, it's just basically telling you you made a mistake somewhere. And because it can't even figure out what mistake you made, it just says, you know what, screw it, do it over again. It's done. So you have to be really, really careful about that. So X has to be an integer, N has to be an integer. You get those messed up, bad things happen all over the place. So what was the other
Got
question
it.
that you were
Thank you.
asking?
Oh, it was just about the numbers. I was getting the error message, so that was it.
Okay. All right. So does this seem and feel like it's been a lot already?
A little, yeah.
Yeah. Yeah, just wait until we start using SPSS to do some of this stuff. Um, and with the SPSS, I will show everyone two different ways that you can actually access it. One of them is to go through My Lab and get it for free. The other way is you can actually just download it onto your computer and pay like 30 bucks for a year rental or something like that. Having it on your computer is a lot easier than using any lab or Lab Anywhere, but Lab Anywhere is free. And again, if you are in a situation where you have to make a decision, do I spend $30 on, say, food and gas for my car so I can go to work, or $30 on software for this class? You better be getting food and gas. Now Brooke's back, so she can ask the question she was asking before I interrupted.
I'm sorry, my computer just like totally glitched out. I don't know what happened.
No biggie. So you're
So
back now?
yes, so my question, I had to just step out for a moment right at the beginning. So your little chart, I missed that. And I don't have a graphing calculator, so I was just kind of just watching you plug it in.
Yeah.
And I can look at it, plug it in online from that link that you gave us at the beginning of this course. But I guess like from my point, I I just it's a lot of new information, so maybe it's just a little bit overwhelming for me, and that's how I'm like, so how I view it, we have H HO and that's like our main one, and then the HA is the alternative hypothesis, and then
Mhm.
like I follow that, and then we have the three options how we can determine if like our hypothesis is good or bad, and then
Mhm.
like and then you gave us that formula before you had left, like probability, and then your
Mhm.
graph with the X bar. So I kind of get the concept. It's just now like if I had a homework problem over this, would I be able to decipher anything is the question, and that's kind of where I'm at. Like that's what I think of when I like I don't know.
Well, I'll just be honest with you and say the type of stuff that we just did here is going to appear on the next exam. It's also going to be on the final, which is why I did three different versions of it. Oddly, we're asking the exact same question. The only difference between those three different times was the number of samples we have. So you can glean a lot about what's happening based on that. If you watch the videos that I did with my business school students, the everything that I was talking about with the hypothesis test and everything I was talking about with the assumptions, that was an hour and 15-minute video. So 1.5 class period video. Doing these one prop Z tests and two prop Z tests. That's 1 hour and 15-minute video. So 1.5 class periods. The T tests or the one sample and two sample T tests. That's another 1.5 class period video, which when you add it all up, 1.5 or hour 15 plus hour 15 plus hour 15, it's 3 hours and 45 minutes. Our class, if we didn't have a break, is 2 hours and 45 minutes. So you will have those other videos to look at. If you go to the YouTube thing where I did an online class, those are literally the videos that my online students get at Oakland University. They are literally taking the exact same class as you. But when I made those, I made them assuming a 4 credit class, not a 3. I also made them assuming that most of you will be very, very tired of listening to me talk. So you'll watch those videos at like 1.25 and 1.5 speed. I do have to make a bunch of them because I now have calculator software on my computer versus having to do it underneath my uh, projector over my document camera. Uh, but those are there for you as well. And with all the stuff that we're doing here, uh, one of the big reasons why I don't have like 3 weeks exam, 3 weeks exam, 3 weeks exam, or new material, then a quiz, new material, quiz, new material, quiz, and all that is so you have the opportunity to go back and look. You have the opportunity uh, to rewatch it and try it on your own. You have the opportunity to see 6 different versions of the same thing. So hopefully one of those ways will make sense to you. And like I said, I'm doing everything here and really quickly with my calculator, but I'm also going to show you how to do this for free using a program that is free online. So again, uh, if you have the TI-83, TI-84, what I'm showing you now, wonderful for you. If you don't, do not buy one. Save your money, spend it on useful stuff like food, gas, beer, wine if you're uh if you're old enough for that sort of stuff. So uh you don't have to worry about it too much. But basically what we're doing here is just try to find how we put these things into our calculator and how we understand the results that it's giving. So if I flip over to the table that I had, what ends up happening is the more samples you have, even though we're looking at the same difference between these two, if you don't have enough data, which is the case in when we've only got 30 students, if we don't have enough data to prove there's a difference, we could be totally missing something. So a way we can think about this as an example is we looked at this professor the first semester they taught a class. We come back 2 years later, let's say they've now taught 3 sections or 4 sections of the class. This gives us a better idea about the confidence interval. And the weird thing here is this confidence interval is giving us an idea about what this professor's true pass rate is. Because we rarely, if ever, have all the data and all the data that will ever be for, say, a professor. Or the only way we can do that is say if that professor has retired or has quit and moved on and gone someplace else. For any professor that's actively teaching the same classes over and over and over again, this p hat, so this point estimate that is going to change over time, could go up a little bit, could go down a little bit. We can think of those changes as being, say, corrections. But these confidence intervals are trying to tell us, based upon the information that we have, does this professor seem to have a different pass rate than the population? So 30 students, we fail to reject. 100 students, we reject. 1,000 students, we reject, and we reject it big time. Does that make sense for what we're doing here? Does that make it a little bit clearer, Brooke?
Yes,
Or did that make it worse?
I think it like that makes more sense to me now. Thank you.
Okay.
More less murky. It's yeah. It's just a lot of new symbols in sign. But that
It's
only cleared things up. Like I understand more of the why in what, if that makes sense.
yeah. So in one of the weird things about statistics compared to a lot of the other math that any of you have ever learned is statistics is based on what's called stochastic models and stochasticity. Weird word, just means probabilistic. The math that all of you have learned when you took all of your algebra classes, and if any of you took like a Calc 1 or Calc 2, all of those math classes are what's called deterministic. Um, if you get into philosophy at all, there's the question about, do you have free will, or does God have everything planned for you? If you believe God has everything planned for you, then the world is deterministic. Things will happen essentially because God said so, if you believe in God. If you believe in free will, that means you get to make choices. Because you get to make choices, you have the opportunity to maybe make this choice over here instead of this one. So now you've made this choice over here. Now you have new choices. You could go in two different directions, maybe three, maybe four, whatever. Uh, but essentially, the world is stochastic. Um, and a lot of people mistake probability for, say, if you want to call it that, and I'm not trying to be demeaning to religion or anything like that, but they might call it, say, God's will. Why did uh, someone get run over while crossing the street? Oh, if you believe that's in God's plan, then it's deterministic, and it was going to happen no matter what. And it's a sad thing that that person got hit and bad things happened to them. But it was going to happen no matter what. So deal with it. On the other hand, if you believe in choices, you can look at that same thing and say, why did this person get hit? And then you can say, how can we use this new information to figure out how to prevent other people from getting hit? Um, with deterministic mathematics, 2 plus 2 is 4. And unless I put a whole lot of other stuff at the end of that statement, which I'm not going to, 2 plus 2 is always going to be 4. And if someone tells you different, they're wrong. With statistics, we can say about 2, because we don't know, we'll basically never get exactly 2. We'll have a value that's near 2. Then we can say about 2 plus about 2 is about 4, we hope. So what do I mean by that? If I have, instead of a 2 plus 2, let's say I have 1.6 plus 1.7. If you round those to the nearest integer, you get 2 plus 2. But 1.6 plus 1.7, add them together, you get 3.3. Is 3.3 round up to 4? No. So it's about 2 plus about 2 is about 4. Maybe. We hope. What are the chances that it is? What are the chances that it isn't? So with all this stuff, we get to deal with using the information to basically make better decisions for us. Or if you're going to be working in, say, environmental health sciences, uh, how do you, uh, how can you make a machine that's being used safer in the long run so you don't injure or kill someone with it? Under the current practices, you may have never killed anybody. You may have had a couple people that were hurt, but let's say, for instance, if you make two rules or make two changes to the machine, one, say you have to push two buttons simultaneously and they have to be apart from each other. And two, no one's allowed to wear a necktie or a bolo or anything that comes down. So if you're a woman with long hair and you don't keep it back in a ponytail, or even if you do, um, you have to like keep it back. You have to keep it out of the way. Those could be like two small changes that help minimize the chance of bad things happening in the future. So since it is getting a little bit late and I want to show everyone how to use the online stuff, I will do the two different t-tests that I was talking about next week. It's not going to change too much, but hopefully it'll be advantageous for everyone if we slow down a little bit here. So I'm going to flip this back over. So in that first example, we were looking at what is the probability that a professor passes more students, or we could have looked at what's the probability that a professor passes fewer students than average. Dude, you're still bugging me during this. I'll get you in a moment, don't worry. But this time, I'm going to look at the two prop test. So I'm going to call it, say, Professor A and Professor B. So again, our default setting is going to be, we believe they pass just as many students as each other, or their pass rate is essentially the same. And then we're going to test that against the probability that it's not the same. And again, we're going to look at two different versions of this. Oops. So Professor A and Professor B. And I'm going to say Professor A passes 55% of their students. And this should be Professor B passes, say, 60% of their students. And again, I'm going to go with n equals 100 and then n equals 400. So we're going to assume here that we're looking at two professors. Each professor has taught 100 or close enough to 100 students. One professor passes students 55% of the time. The other professor passes students 60% of the time. Then we're going to up that to 400 students and look at all of this stuff. Again, we can look at a z-score, and this is going to be a calculated z-value, a p-value, and then the confidence interval. And because I said I would get back to this, with the thing that we looked at on the others, with the other one, or with the last test, sorry. So with the p-value, we got, say, 7.6 e negative 19. What does this actually mean? It means we have 0.0, and then we write 18 zeros in a row. And after you've written 18 zeros in a row, you write 7.6. To make it a little bit easier, let's say I have 7.6 e negative 5 for my p-value. This is actually telling me 0.00007 6. So if we round it off at 3 decimal places, the value that you would report, the value you would put on your exam would be 0.000 and be done with it. The mistake that I've seen students make is, again, that p-value out here, the smallest value you can get is 1. Or sorry, 0. The largest value you can get is 1. And when they see 7.6 e negative 19, they'll write the p-value as 7.6. Well, it's got to be a value between 0 and 1. So when I see 7.6, I know what you did, and I'm going to mark you wrong. And even though you say it's 7.6, and the true value is essentially 1 divided by 7.6 billion, or over 7.6 billion. I know where that 7.6 came from. You made a mistake here. That's going to be 1 point off, even though you are like literally over a trillion off. It's only a 1 point mistake because I know where it came from. I know you're going to make that mistake. All right. So let's get back to the calculator. So again, shoot, getting ahead of myself here. So again, with both of these, probability A is again going to be XA. So the XA is the number of students that Professor A passes, divided by NA, the number of students that Professor A taught. Your calculator wants the number of students that passed divided by the number of students taught. And with the information we have here, we have the PA, we have the N. So the basic formula I'm going to use is XA, and this is for the calculator. It's going to be PA times NA. So the PA is again 0.55. NA in this case is going to be 100. 0.55 times 100 is going to be 55. For Professor B, same thing. XB is the number of students Professor B passed. NB is going to be the number of students Professor B taught. So in this case, XB is just going to be this PB, so the probability Professor B passes someone, times the number of students Professor B taught. Using this first calculation, we're going to have 0.6 times 100. That's going to give me 60. Okay. So now when I put these into my calculator, so again, I go to stat, over to tests. This time I'm testing 2 different proportions. So I'm testing Professor A versus B. This is going to be the 2 prop Z test. Then I hit enter. My first value, Professor A passed 55 out of 100 students. Professor B passed 60 out of 100 students. Again, for this, I am just looking at, is there a difference between them? I'm not looking at, is one professor better than the other? I'm just asking, is there a difference? So I can come down to calculate, hit enter. The z-score that I have up here turns out that it's negative 0.7151. So I'll say it's negative 0.75. The p-value that we use is the next value down. So 0.474. P1 hat gives you the point estimate for Professor A. P2 hat gives you the point estimate for Professor B. The p hat here is just basically the average of those two values. If I had Professor A taught 200 students, Professor B taught 150, this p hat would be based upon that. Now I need the confidence interval, so I go back to stat, over to tests, and then drop down to 2prop z int. Big question for me is, why doesn't the calculator just do all this stuff all at once? Make your lives a whole lot easier. It doesn't, but can't do much with it. So I'm going to hit enter. And the confidence interval that we have here is negative 0.187 to 0.08. So it's 8685. So if I go out to 3 decimal places, it's 0.087. So based on the Z calc, if I have that particular table memorized, I can say, okay, it's not statistically significant. To make it easier for me to figure out, I can look at the p-value and stop the share real quick. This is going to tell me this is above. So in this case, shady area is 0.05. This 0.474 is in the clear. So essentially, we're going to say in this case, we failed to reject the null hypothesis. So at this point, we cannot tell the difference between these two professors. And the confidence interval that we have here is actually telling us based upon the difference between these two professors. The negative value here means that we believe, based on this data, Professor B could actually pass students at a rate up to 18.7% higher than Professor A. Because we've got a positive value over here, this is also saying there's actually a chance, again, based upon our data, that Professor A passes more students by as much as 8.7%. You look at the data and you're like, Professor A passes 55% of their students, Professor B passes 60%. This is telling me there's a chance Professor A has an actual higher pass rate, which goes against a lot of thought that most of us would have on this case. To do this next one really quickly, again, if I'm using 400 people, again, it's going to be 0.55 times the number of people to get XA. And then for Professor B, 0.60 times 400. That's going to give me XB. So XA and XB. 60% of 400. I already know that's going to be 240. 55% of 400. It's going to be what, like 100 or 220? so I'm now gonna put XA, so this is saying 220 of the 400 students Professor A taught passed. So I'm gonna clear this out on the bottom. Probably need to hit the share button too, so you can see what I'm doing. That would always help out, right? When you can see what I'm doing. All right, so again, gonna go to stat, over to tests, down to, oops, sorry, 2-prop z-test, so this is number 6. I'm now gonna enter the new data. So I'm saying 220 of 400 students passed Professor A's class, 240 of 400 students in Professor B's class passed. We're going to look, is there a statistically significant difference going on here? Come down here, hit calculate. And even with 400 students, the z-score is again a negative 1.43. The p-value is 0.1526. So I'm going to round it to 1.53. To get the confidence interval, I go back to stat, over to tests, then just start mashing the down arrow again. So I've now got the 2-prop z-int. Click on there. All of my information is already entered. So I can just hit the down button or start mashing the enter button. The confidence interval I have here is now negative 0.118 to 0.0184. At 3 decimal places, it's just going to be 0.018. So again, this information is telling me that it's possible that Professor B will pass about 12% more students than Professor A. But it's also possible that Professor A, even though we're looking at 400 students, Professor A might actually pass about 2% more students than Professor B. When you look at the data that we have here, even at 400 students, we can't say Professor A passes more students, okay? It's an odd thing to think about. If all I did was say, gave you that data, said, and I asked you the question of who would you rather take class with, Professor A or Professor B? You would look at that, you'd say, well, Professor B passes 60% of their students. Professor A passes 55% of their students. I would go with Professor B because they pass a higher percentage of their students. And I totally would not blame you for saying it like that. You talk with most people, you could use that logic and they would completely 100% agree with you. But quite literally, what we just found is that even at 400 students each of these professors is taught, that's still not enough information to say that one is better than the, or say that one is different than the other. And even if you went back and said, well, I don't care about different, I want to know, is Professor B better than Professor A? We could do that calculation and you're still going to find we do not have enough evidence to say that. Fully admit it's totally weird, but that's kind of how this comes out. Now, Brooke, you were saying you don't have a graphing calculator, right?
Correct.
Okay. between Abby, Carmen, and Lonnie, do any of you, or do all of you have a graphing calculator?
I do not have one, but I just use the online one, or there's like an app you can download on your phone, and I use that.
Okay. What about you, Carmen or Lonnie?
I've been using one online too.
Okay. So I'm just going, I hated how Windows decides how to rearrange everything for me. So I'm just going to go to a website that I'm familiar with. So StatDisk. Did I show you guys this website already?
Yes.
Okay. So StatDisk Online. So just to recap, are you sitting on the papers? Trying to find the notes I had earlier. Where did I put that? Did you read my paperwork, Kat? Shoot. Oh well.
I love
Uh,
It's funny.
I'm just trying to find the notes that, all right. Is this? Right now my cat's just looking at me like, dude, you're making angry noises. I do not appreciate that. Please stop. Shoot. Oh well. So anyway, if I'm going to be using StatDisk, I believe it's under analysis. If I want to do the confidence intervals, so I have the one sample and two proportion one sample, proportion two sample right here. I have hypothesis testing for one proportion and two proportion right here. So if I'm going to do the two proportion sampling, you can see up here, I've got options that are actually fairly clearly marked, which is very, very nice. Population proportion one not equal proportion two. So that is the same test that we did. Significance, we have that at 5%. That gives us a 95% confidence interval. So if I try to do the calculations we just did again, sample size N1 is 100. Number of successes for N1, so doing the original thing with 100 students, is going to be 55. 100 students for Professor B, and 60 of those students passed. Now I can click the evaluate, and it shows you right here the T statistic, and there might actually be a way to make this a little bit bigger. So if you are having some visual issues, you might be able to make this easier for you. I honestly don't know. This is telling me what is the critical value for Z based on my data. It's given me the p-value for my data, and it's also given me the confidence interval for my data. Now, if I do the second example problem where we have 400 students, and I said 220 out of 400 pass, then for this professor, they had 400 students as well, but they had 240 pass. I can now hit the evaluate button. Again, it gives me the test statistic, the Z critical value, and the P value, and the confidence interval, all right there. Let's say I want to do it for 500 students. Sorry, I got to pull this up real quick. So 0.55 times 500 275 students. And this professor also taught, let's say, 500 students. 300 of their students will pass. Now I can evaluate that. And even if we get this to 500 students per professor, the Z value we have here is less than the Z critical value. The P value here is still above 0.05, so we still cannot tell if one professor has a higher pass rate than the other. And we have the confidence interval right here. Now with data like this, just as an example, let's say we want to look at, is proportion 2 bigger than proportion 1, which is probably the question a lot of students are going to be asking. We don't care if they're different. We want to know, is Professor B better than Professor 1 or Professor A? Make that change, hit the evaluate button. You see the test statistic for that versus the Z critical value. The test statistic is still smaller, telling us we still don't see a difference. The p-value is 0.055 or 0488. Call it 0.055. That is above 0.05. So the p-value is still telling us that there is not a statistically significant difference even at 500 students each. So if I want to go back, can do the hypothesis test again. So one proportion or one sample proportion. Unfortunately, I can't find the sheet that I had with all that information on it. So I'm just going to say, go back and say, I believe I said 53% of all students that take a certain class pass it. Now, if we're looking at, say, that Professor B who passes 60% of their students, and if they have 100 students, we know that 60% of them pass. And again, come up here, I've got 3 different options. I'm just going to keep it as is there a difference? I can hit evaluate. Gives me the test statistic, the Z critical value, and even the p-value here, as well as the confidence interval down here. And it's all telling us that at 100 students, we cannot tell the difference between a professor that passes 60% of their students, even when the proportion of students that pass is 52%. So we can't say 60%, a professor with a 60% pass rate is better than 52%. Now, if I go with the values I had at 400 people, so that was 240. So if I evaluate this, now my Z statistic is much larger than the critical value. The p-value I have is well below 0.05. It's 0.00136. So you can round it to 0.001. And you can see that the confidence interval that I have here is 0.55199. Call it 0.552 to 0.64801. So I can say it's 0.648. So essentially, I believe that this professor will pass somewhere between 55 and say 65% of their students. My best guess as to what percentage or they will pass is actually going to be this 60%. But I would expect if everything we look at here holds true, and we look at this professor when they retire or when they quit teaching at the particular university or whatever, based on the data I have now, I would suspect that somewhere between 55 and 65% of their students will have passed. Does anyone else think that my voice is a bit hoarse right now?
Yes.
Yeah, been talking since about 8:30 this morning, so hopefully, Brooke, that helps you out with trying to do these types of problems.
Yeah.
And for all my students, if we're doing or when you're doing the next exam, if you don't have uh, a calculator and you need to use this, feel free to ask me for help. We can spend 15, 20 minutes. We'll do a couple example problems together to hopefully give you better confidence that you're actually doing it correctly. Uh,
I would.
and I think I need to do some major drinking right now. Probably finish off my lemonade iced tea. So with that, uh, are there any other questions from those of you that are still here?
I have a quick question. Do you have can you is there homework over this? If so, could you release it or
Yeah,
give us a problem?
yeah. I think the homework that I have over this though is based on the proportions which we have now and the t-tests that we will do next week.
Okay.
So I'll probably release it next week instead of this week.
Okay.
Okay.
The only thing I was gonna add is first, I appreciate you being lenient with my test. That was a lot to take in at once, but
Okay.
I got through it. And I submitted that, and then I wanted to say I was gonna submit that other homework assignment tonight if I can, or tomorrow if that's okay. The
Well, I'm not going to be grading any of the exams until at least tomorrow.
okay, my exam's
When I
in.
start, yeah, and with the homework, I'm not probably not going to be looking at that until the weekend anyways.
Awesome.
So,
Thank you. I really appreciate you being lenient with it because I'm trying to take it all in, but it's a lot. It's out of my
yeah,
comfort zone for sure.
yeah. Is everything that I'm doing high enough contrast for you?
Yeah, so far it has been. I mean, it takes me a little bit more time just to get like acclimated sometimes, like when it's something new. But so far it's been pretty okay. And then I'm gonna be honest, my mom is kind of like familiar with a little bit of the just like Excel in general. So when I've like really struggled, she's been
Okay,
able to kind of steer me in the right direction. So that's been helpful.
right. So something else that would probably be beneficial to you or could be, I'm going to assume that you have a TV at home.
Yes, I do.
Safe assumption, right? Um, just for me personally, when I'm working on like my home computer as opposed to my laptop, I actually use a 32-inch TV as my monitor for my home computer. And I have actually connected my home computer to my 55-inch TV that I have in my bedroom.
Yeah, it is a good idea. It is helpful, isn't it? My mom has
Yeah.
a pretty good. I've been doing it at my parents' house a lot of weeks. I sit upstairs in there. She has like an office set up, and she has like three
Mhm.
monitors there. So it's been really helpful to. I've actually never used a system like that, so it's kind of cool.
Yeah. One of the um just a little bit off topic, but not quite that much. Many years ago when I was dating or still with my ex-fiance, I knew that she was going to get into weather forecasting. That was her goal. That was her dream. That is what she wanted to do. She wanted to be a broadcast meteorologist. And when we moved her out to where she ended up going to grad school, uh, at her parents' house, they had like a 27-inch CRT, so cathode ray tube TV. When we got out there, I bought her, I think it was a 60-inch TV. So she's going from 27-inch to a 60-inch and then looking at me and yelling at me, uh, why is this so big? I don't need a TV this big. I can see fine. And then she watched it and was like,
This is kind of
oh
nice.
my God, this is awesome.
That's cool.
And yeah, and quite literally what she did, um, so this is like after she broke up with me. She ended up getting her master's degree in atmospheric sciences. She moved back home with her parents for a little while. She got an internship at Detroit's Channel 7 newsroom. So she was actually like an intern there working with the Channel 7 weather people that were there at the time. And she created what are called reels so that she could like show how she's at the level of, say, professional broadcaster. What did she use? She didn't have the big green screen that they have at Channel 7 or any news affiliate that you watch. She had that freaking 60-inch TV. So
That's
she
funny.
hooked up her computer to the TV and then pointed to things on the TV,
That's
and
funny.
it worked out wonderfully.
Yeah, I bet it did. That's awesome.
Um,
For her.
but
It's cool.
yeah, but I'd say for you as well, though, like I noticed when we were talking, uh, however long ago it was, you kept like trying to get closer to the screen and all that.
Yeah, yeah.
Totally understand it. Um, but if you're going from, say, looking at things on, say, a tablet or a 13-inch laptop versus 32-inch
That's something
TV
bigger. It's different. Yeah,
versus a 55-inch,
for sure.
um, I would hope that would be a whole lot better for you.
Yeah, yeah. It's definitely worth trying it, honestly. It is cool to have it on the screen she has on her monitor are a
Yeah,
little bit bigger. So that's been good. But yeah, no, what you're talking about would be a whole nother
yeah,
ballgame of
yeah,
screen size.
yeah. And I'll be honest too, my brother does a lot of CAD programming. He
Okay.
doesn't have a monitor. He has an old 32-inch TV that he
Oh
used to have
yeah.
in his bedroom.
Makes sense.
That is his computer monitor.
Yeah.
And even for me, if say I'm doing some work on my laptop, there are times when I need to zoom in a whole lot. And then I start thinking, maybe I'm really am that old. Maybe I am
Yeah.
having that much of a sight difficulty. Then I'm like, no, I'm just an idiot because I can plug this up to my 32-inch TV and I don't need to
Yeah,
zoom in as
right.
much and it's higher quality. I'm like,
Yeah, it
why
makes
didn't I
things a
think of
lot
that sooner?
easier. Well, thank
Okay.
you very much. I really
Yeah.
appreciate it.
And just so that you know, if you do need, or if you have, say, a laptop
Hmm.
and you want to put it on the TV, there
Hmm.
should be a video output on the laptop. On all the computers I've had recently, it's been a standard HDMI. You can
Hmm.
buy a standard HDMI cord pretty much anywhere,
Yeah,
and it's just that one cord to the
cool.
back of the TV.
Right.
I will mention too, though, with most TVs, it can be kind of difficult trying to figure out what port did you just plug
Yeah, I
that
was gonna
into.
say which setting to put the TV on.
So for
Yeah.
that one, you're gonna want to be like, hey Ma, hey Dad,
Yeah.
if you have a brother, sister, hey bro,
Yeah.
hey sis, if
Yeah.
you have a boyfriend, you have a girlfriend,
Yeah.
hey, come on over, can you help me with this? Plug it in, which port did it go in? And then watch them go, I can't read that. How am
Yeah.
I supposed to see it?
Give me a little a little sense of being
Yeah,
the same as everyone
yeah,
else.
yeah. But eventually you would be able to see it, and all of a sudden I can actually put the screen from my laptop onto the 32-inch mount TV, I can put it on my 60-inch TV. I
Yeah.
can go out in the living room, put it on my 55-inch TV that's out there. So
It's a pretty,
many
pretty cool
options.
technologically advanced world we're living in these days.
Yeah. Yeah. So again, if you are having some issues, um, I've been even without really thinking about it, I have been trying to be as conscious of people that have visual difficulties, whether it's something on the color spectrum or you just have really, really bad eyesight for whatever reason.
Yeah.
I'm hoping that the color contrast that I have is good enough.
Yeah, it's been good so far. I was gonna say, I can tell you from experience, we appreciate it because it's pretty annoying when you have to worry about it in all your classes.
I've had I've actually had some professors before who will start writing drawing things on there or on the screen or whatever,
Yeah.
and they'll be using